All right, guys, good morning. So plan for today and then just for the next week or so. So we're nearing the end of the first quarter. So we are gonna do our last notes today. Then we're gonna review for, it used to be called a QSA, now it's called a CIA. Basically, it's just the district test that they give you with, or like a benchmark, it's the same thing. So we're gonna review for that next week on Monday. And then, or wait, today is Thursday, yeah, so on Monday, and then you guys will take the CIA on Wednesday. Okay? So that's kind of the general idea. Also, if you did not take your test last week, I'm gonna have you take it today because our notes are short, yes? I think it's not next, it's, October 11th, I think. But it's not next week, but it's the week after. But your last grade for my class will be next week. All right, so we're gonna run through just a couple of quick things. And then I'm gonna have my kids that need the test take it right after that. So if you are asked to find whether or not something is a function, do you remember that you do the vertical line test?
Yes.
Okay, and that also means that your x's can't repeat. So for example, you couldn't have, we'll do not a function if you had, let's say 2 is with 3 and 2 is with, let's say 6. Okay, and the reason why is because if I graph these 2 points, they'd be right on top of each other, that my vertical line would cut through both of them. And my x's repeat, that's not allowed if it's a function. Now we're gonna add to that a 1-to-1 function. Not only do the x's not repeat, but the y's can't repeat either. Okay, not only can the x's not repeat, but if it's 1-to-1, neither can the y's. Vertical line test is when you draw a line through the graph that it can't cross through twice. Okay, then go to the next one. Not only does it have to pass the vertical line test, but it's gonna have to pass the horizontal line test. Okay, so we're gonna come back to these, or actually, no, let's just do them right now. Okay, so I'm looking for no repeats at all. So 1 goes with 2, 2 goes with 4, 3 goes with 6. Number 1 is 1-to-1. Okay, because there are absolutely no repeats, no numbers that go with multiple partners. Okay, versus in the second graph, which number is going with 2 different values? Okay, my 4 here, and it's partnered with 2 different numbers. This is not 1-to-1. Okay, remember that 1-to-1 means not only can the x's repeat, okay, but neither can the y's. Okay, and then last one, do we have a number that's going with 2 different partners? Okay, 4 again, splitting off with 2 and -2, so that is not 1-to-1. Okay. All right, next we're gonna look at the graphs. So we're just gonna sketch the graphs of the bottom 2. Do we remember what an x squared graph looks like? Parabola, very good. And then the +5 shifts it up 5, right? So I'm gonna go 1, 2, 3, 4, 5. There's my u. Okay, you could graph it more specifically if you want. Okay, but let's do the vertical line test on it. If I do any vertical lines through this, are they ever gonna hit it twice? No, so it is a function. Okay, but the horizontal line test says it also has to pass this way. And if I draw a line through it this way, is it gonna hit more than once? Yes. So I'm gonna go ahead and draw that line in here. This way, it crosses twice. So it fails the HLT. Okay, which is the horizontal line test. Okay, so I'm gonna put it passes the VLT, which means that it's a function. Check. But because it fails the HLT, it is not a one-to-one function. Okay? So VLT makes it a function, HLT also makes it horizontal. Let's take a look at the next one. Does anyone remember the shape of an X cubed graph? It's a squiggle, okay? And then the 4, now notice they put the 4 in the front, but that's the same as a +4 in the back. So which way is the +4 gonna move my squiggle? Okay, so 1, 2, 3, 4. Then normally your squiggle starts at the bottom and it goes uphill. Why will this one not do that? Negative in the front, so start at the top and you're gonna do your squiggle downhill. So we're just gonna go like that. Okay, question, will it pass the vertical line test? Okay, I draw in my vertical lines, will they ever hit it twice? Then it passes. What about horizontally? If I slice it this way, am I ever gonna hit twice? No. So then I would put it passes the VLT. It passes the HLT. So that means it is one-to-one and it's a function. I'm just gonna put check. Okay, and hopefully we know which one's which. It's the VLT that makes it a function. It's the HLT that makes it one-to-one. All right, turn the page when you're ready. Okay, so we talked about one-to-one. The other thing we have to talk about is just commutative functions. Okay, so commutative functions, basically what this means is that if I do f of g, I should get the same thing as if I do g of f. So commutative basically means that like the order doesn't matter. An example of that would be 1 + 2 is 3. 2 + 1 is also 3. So it doesn't matter which way you ordered them. Okay, so let's try this question. If we do both orders and they come out to be the same function, then we know it is commutative. So let's start off with f of g. Then we'll do g of f. Okay, we'll try both ways and then see if they come out to match each other. Okay, the way that you do this, some of y'all on your test did well on this, some not so much. Okay, but f is 3x minus 4. I'm gonna do 3 blank minus 4. And then in the blank, I'm gonna take the equation for g and I'm gonna put it into that spot. So my g equation is 1/3 x plus 4. What happens to a times 3 and a divide by 3? Cancel out, which means really there's nothing in the front anymore. So I can drop my parentheses. I have an x plus 4 and an x minus 4. Now my plus 4 minus 4 cross out, I'm just gonna get x. If it comes out the same way, when I reverse the order, you would say they're commutative because the order doesn't matter. So let's start off with g's equation. G is 1/3 x plus 4. Now it's blank plus 4. 1/3 blank plus 4. And then into the blank, I'm going to insert the equation for f. So f is going to be what fills in the blank here, which is a 3x minus 4. Inside the parentheses, can anything cross out? Yeah, minus 4 and plus 4 cross out. And then really all I have left is 1/3 of 3x. But what is 1/3 times 3? That's another times 3 divided by 3. That's going to cross out and just give us what? X. Okay, so because they both came out to x, you would say yes, these are commutative. Okay. And what I just explained to you okay, should always happen if your functions are inverses. So if on your homework it says verify if the functions are inverses, basically just plug them into each other. If they come out the same, the answer is yes. If they come out to be different, the answer is no. So let's just do maybe one of these. Let's do number 3. Okay, if these are inverses, when I plug them into each other, everything basically should cross out. You should just get an X left over. So we're gonna skip 2 and go on to 3. So I'm gonna do f of g first. Then I'm gonna do g of f second. So for f, I'm gonna do square root 3 blank minus 7 plus 10. Notice that where the x is in the equation, I'm leaving a blank there because I'm going to take my g equation and I'm going to drop it into that spot. So it was an x plus 10 over 3 squared plus 7. Yeah, I should have made my blank a little bigger, but there you go. Okay, first thing I'm going to notice, I have a plus 7 and a minus 7. What can we do with that? Cancel them out. Okay, the next thing I notice is that I have a times 3 and a divide by 3. What's going to happen there? Okay, so I have x plus 10 squared over 3. The 7s are gone, plus 10 on the outside. Okay, we said our 3s are going to cross out. So now I have the square root of x plus 10 squared. What's going to happen when I have a square root and a squared? Cancel out. And then the only thing that's left is a plus 10 and another plus 10. Do those cancel out? No. What's 10 plus 10 more? 20. That means that these are not inverses. Everything has to cancel out for them to be inverses. And the only thing that you should be left with is an x by itself. Okay? So if both sides come out to x, yes, they're inverses. Do we feel okay with that? Okay, turn the page one more time. Last thing. Okay, we have learned already at the top, if you'll read that for me, okay, that an even degree means the highest power is even and the ends go the same way. Do you remember talking about that? Okay, and then same thing for odd, that an odd degree means your ends are opposite, your highest power is odd. Okay, that's even degree. If it is even, purely even, okay, read this, you have to have symmetry across the y-axis. So look at this first graph. If I look at the y-axis right here, do you see how both sides match? Yeah. That makes it even, not even degree. It is also that, but it's purely even. Okay, and if it's purely even, then both sides have to be identical. It is also even degree, okay, but purely even means both halves match. Same thing here, same thing here. We get it? Okay. Come down to odd. An odd degree is what you've already learned. One ends up, one ends down. Your highest power should be an odd number. Okay, but an odd, purely odd function has symmetry about the origin, which means that if you rotate it 180 degrees, then it should look exactly the same as what it is right now. So, for example, if I take this line and I spin it 180 degrees, do you see how it would end up in the exact same position? Okay, same thing with this one. If I were to take this graph and I were to spin it 180 degrees, it would end up in the exact same position. Okay, last one here, spin it 180 degrees. This little hump would end up on top of this hump and it would look exactly the same. That would be purely odd. Okay, so odd degree just means your ends are opposite. Odd by itself means not only does it have to be opposite ends, but it has to rotate back to itself. So we're going to do a couple graphs across the bottom, then we'll be done. Okay, take a look at the first one. Negative x squared minus 3. We're going to sketch it And then we're gonna determine if it's even or odd, or even degree, odd degree. So for the first one, I have a -3, which way is that gonna shift it? Down 3. And then if it's a negative x squared, that makes it a u, yeah? I'm gonna draw it in like that. Okay, first question. Is it even degree or odd degree? Even, because the ends both go down. Is it also even? Yes, because why? Because it's symmetric, very good. So I'm gonna put that this is not only even degree, but it is also even. And it's harder to be even than just to be even degree. Okay, look at the second one. Which way will my -3 shift my graph for this question? So 1, 2, 3. And it's still a U shape, so I'm gonna draw it in. Is it even or odd degree? Even, but is it purely even? No, because when I look at my y-axis, do you see how it doesn't split the picture in half? So you're gonna put that this is even degree, but not truly even. Okay. One more left like that, absolute value x -2. Which way does the -2 move the graph? Down 2. 1, 2. And then if it's absolute value bars, that means it's a V, right? I'm gonna do my V right here. Whoop. Whoop. Is it even or odd degree? Because the ends are together. Is it also purely even? Yes. Okay, because that y-axis perfectly cuts your graph in half. That makes it even. And when I say even, I'm referring to purely even. Okay, it is also even degree, but even is a harder criteria to meet because it has to also match on both sides. Okay, for these next two, actually, let's do this one. We may need to use a calculator for that one. Let's do this one. Square root x is the hook. Which way is the +3 gonna move it? Okay, up 3, so 1, 2, 3. Then draw your hook. Is that even, odd, or neither? Take a guess. Okay, this is a neither. Here's why. You don't even have another end to look at, right? So your ends can't be going the same way if one of the ends doesn't exist. So I'm gonna put this is neither. It's not even or odd. Okay, last one. Can I steal your calculator for the graph? Okay, last one. It's y equals x cubed minus x. Let's see what it looks like. Okay, sketch your graph right here. Okay, so it looks like it goes up, down, up, like that. Okay, just do your best. Is that even or odd degree? It's odd because your ends are opposite. Is it also purely odd? If I take my graph and I swivel it 180 degrees, would it be in the exact same position it's in now? Yes, it would. Okay, if you're not sure, look at it and then just flip your paper. See how it looks the same? Okay, no matter which way I do it, that means that this is not only odd, but it's not odd degree, but it's purely odd. Because if I swivel my graph 180 degrees, it would look exactly the same. Okay, last little bit of this. The only function, okay, or the only graph that could be even and odd would be a circle centered at the origin. So let's just kind of draw, just do your best here. Okay, if I consider the y-axis, does it perfectly cut your circle in half? That makes it even. If I twist the circle 180 degrees, would it end up in the exact same spot? So it's even and odd, but is it a function? No, because what does it fail? Okay, very good. So if it asks, determine if it's a function, you would say, no, it fails the VLT. It's also not one-to-one because it fails the HLT. So I'll put that too. Not 1-to-1 because it fails the HLT. So the only way that a graph could be even and odd, basically it'd have to be a circle so that it's symmetric with a rotation and with a reflection. Okay, but that graph would not be a function because it can't pass the VLT. Okay, do you feel like you can do it?
Yes.
All right. So if you need to take your test, then tell me in a second. Everybody else, you can go ahead and start on your Delta Math.